me get out my thing here first of all. You flip the if and the then of a conditional statement. Sometimes they'll be true, sometimes they won't. As we looked at the bank robbers. So here's a conditional statement. If you live in Dexter, then you live in Michigan. Is this a true statement? Here's the if, here's the then. Is this a true statement? If you live in Dexter, well, we're talking about our Dexter, okay? Then you live in Michigan. We're going to say yes, this is a true statement for this one. I'm going to assume that we're talking about our Dexter here. Let's write the converse. If I write the converse, I'm going to switch the if and the then. If you live in Michigan, then you live in Dexter. Is this a true statement? No. Because we can prove it wrong. Okay, there's other Dexters, I'm sure, in the country. This is not true. You could just say, I live in Ann Arbor. Right? All right, some very important true converses. Corresponding angles postulate. You were using this on the quiz. You were. You might not have even known it, but you were using it. It says if two parallel lines are intersected by a transversal, then corresponding angles are congruent. So what they did here, draw this picture. They told us we had two parallel lines. They told us that. And they told us there was a transversal. This is in the last 4 sections that we've had. Because of that, we know that angle 1 and 4, which are corresponding angles, are congruent. We can say that. We can say that that is true because these are parallel lines. Now the converse to this is saying if, how would I write it? This would become if. How would I write it? Exactly. If corresponding angles are congruent, then the two lines cut by the transversal I'm going to stop there and see if you can finish this statement. What am I trying to get at? If corresponding angles are congruent, then the two lines cut by the transversal are what? Parallel. Parallel. So it's looking at it, they do intersect on, but it's looking at it as the fact that if they tell you they're congruent, then the two lines cut by the transversal are parallel. It's like a flip-flop. Here they told us it was parallel, then we found out that the angles are congruent. Here, we're saying corresponding angles are congruent, then the two lines are parallel. Okay? That's the difference. So turn the page. There's three more, because we did talk about these three other types of angles already. So, look, I typed it up for you. I was going to make you write it, but I decided no. Here's the converse to alternate interior. In the quiz, if you were given two parallel lines, you knew alternate interior angles were equal. Well, here, if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. If then. So they're saying if I have two lines, I don't know they're parallel, but I know they're cut by a transversal, because it's telling me that. And then it says that the alternate interior angles are congruent. Angle 2 is congruent to angle 3. If I'm given this information, what can I say about those two lines? That they are parallel. Then I can draw these little arrows which tell me they're parallel. Okay? This is the converse of Theorem 3.5 on page 129. Now on Wednesday, you're going to be typing up all these theorems and their converses yourself. So that's why I'm having you write this down. It's the converse of theorem 3.5 on page 129. Okay, this one is saying if two lines are cut by a transversal so that the alternate exterior angles are congruent. Okay, two lines cut by a transversal. The alternate exterior, that means like up here, and where else? Here? Here. Alternate exterior angles are congruent. So they're telling me that angle 1 is congruent to angle 8. Because of that, I can say what about those two lines? They're what? No, what can I say about these two lines if these angles are congruent? What? They're parallel. You should not have any phones out. You should not have any iPods in your ears. Nothing right now but notes in front of you. Okay? Nothing. Take it out. I'm asking for 15 minutes of your time. Okay? All right. Consecutive interior converse. Oh, I'm sorry. This is the converse of theorem 3.6 on page 130. Okay, consecutive interior converse. If two lines are cut by a transversal, okay, again, I have two lines cut by a transversal. So that the same side, I'm going to write that as consecutive, interior angles are supplementary. What does supplementary mean? 180. Add to 180. So I'm going to say 2 and 4. 2 and 4, those are consecutive interior angles. They add to 180. If this is true, then I can say what about these two lines? They're parallel. I can say that they're parallel. Okay? If these two angles add to 180, this is what they're telling me. All right. This is the converse of theorem 3.7. I think that's also on page 130. Okay, here's how you're going to use this stuff. Practice. Is it possible to prove the following lines are parallel with this given information? If so, which postulate or theorem would you use? All right, they want to know if I can say, if they tell me that angle 1 and angle 5 are congruent, can I prove that these two lines are parallel? This is where you kind of have to know your types of angles. Angle 1 and angle 5 are what kind of angles? Okay. If they're saying that this equals this, that's enough information to say these lines are parallel? By which theorem? Which one? Oh! If corresponding angles are congruent, then two lines cut by the transversal are using the corresponding angles. Converse. Okay, angle 2 and angle 5. Is there enough information using 2 and 5 to say these are parallel? Based on these four converses that we're talking today, is there enough information? No. Because 2 and 5 aren't any of these kinds of angles. 2 and 5 aren't any of these kinds of angles. Okay? All right, let's look at C. Measure of angle 4 plus the measure of angle 6 equals 180. Oh wait, this picture does not relate. Let's cross that off. I don't know how that ended up there. Okay, I know. Measure of angle 4 and the measure of angle 6 add up to 180. Is that enough information to say those lines are parallel? Based on which one? Yeah, these are consecutive interior angles. Yes. Consecutive interior converse. Okay, angle 2 and angle 7, right here. What kind of angles are these? Alternate exterior. They're saying they're congruent. Therefore, I can say, yes, these lines are parallel based on what? Alternate, exterior, converse. It's saying if they're congruent, then the lines are parallel. Yes. Is this clear so far, what you're going to be doing? You're going to just kind of be using these. Let's look at this. Right here and right here. I need to show that this is going to be equal to this because I want to prove these lines are parallel. So I need to find what value of x would make this equal to what number? 98. So what I do is I say, okay, 5x minus 7 equals 98. Because I want to know what this number is that will make this angle be 98 degrees. So I use algebra, yeah. Add 7, thank you.
Divide by 5.
And then divide by 5. X equals 21. You want to find that out because if you plug 21 in here, it's going to equal 98 degrees. And then you have corresponding angles that are congruent. And you can say that these lines are parallel. Okay? Can I do anything with this? Okay, right now, these two angles are nothing special. I can't really do anything. However, you guys learned something from the before chapter. What did you learn, Julia? Yes, you do. It starts with a V. Oh, if this is 100, what's this? 100. Oh, now wait a minute. Now I have consecutive interior angles. And what do I know about consecutive interior angles? Yes.
I know that they're 180.
They add to 180. So they add to 180. Yeah, I know you can do it in your head, but write it out.
Yeah.
100 plus 2x equals 180. Subtract 100 from both sides. X equals 40. So now, if I have 2 times 40, this becomes 80. And now I can say, yes, these are parallel because these add to 180. I found out what x value made that happen. Make sense? All right, let's look at this one. I got an angle here and an angle here. What kind of angles are those? Okay, what do you know about alternate interior angles? If these lines are parallel, these are going to be what? Equal in measure. Equal. I'm sorry, what did you say, Tristan? What? I get negative 2x equals negative 44. Divide by negative 2. X equals 22. Ladies and gentlemen, if you got a negative x value, would that be a problem? Yeah, because you can't have a negative angle measure, can you? No, you can't have a negative angle measure. So this, if I plugged in x, this would be 88. And if I plugged in x here, this would be 88. Now I can say these lines are parallel. I found out what x makes that happen. All right, last one. What do I do here? Leah, what do you think? These are what kind of angles? Alternate. Outside, you gotta know this. You gotta know it. It's not going away. They're alternate what? Right on. Which means that they are what? Equal. So set them equal to each other. 5x equals 70. X equals 14. All right. Now,